Which similarity transformation maps triangle ABC to triangle DEF? Well, what we have here is we have a sequence of transformations, and each one has some sort of dilation included. We either have a dilation of 1.5, or we have a dilation of 2 being involved here. Answer choice A would show a dilation of 2 because I have a 2 in front of both the x and y coordinates. But then this negative would represent a reflection across the x-axis because the y-coordinate would change. So this is saying a reflection across the x-axis after a dilation with a scale factor of 2. That's what choice A is saying. All right, so because these all involve doing a dilation first, let's write out the coordinates of our original points, or our pre-image points, and our image points. Let's start off with the pre-image points. Point A is at -6, -4. Point B is at -4, -2. And point C is at -2, -5. And now let's look at our image points. So point D is at -9, +6. Point E is at -6, +3. And point F is at -3, 7.5. And we also know from dilations, when you're dilating about the origin, the scale factor also relates the coordinates that we have here. And since the sign doesn't change for the x-coordinates, we can set up a ratio between them to see what it is. So that would be -9 over -6, which is going to reduce to 3/2, or 1.5. So therefore, I also know that the dilation is not 2 that's happening here. If it was a dilation with a scale factor of 2, this point A would go to -12, -8. Well, we're looking for something that has a 9 in it, and -12 doesn't have that. So we know that the dilation scale factor is 1.5. So we can cross out choices A and C because they say that we have a dilation of 2, which is not happening. All right, so now we know that the dilation is of 1.5. The question is the second transformation a rotation 270 degrees about the origin, or is it a reflection across the x-axis? Well, let's actually do that dilation with the original set of points and then relate it to what we have up here. So let's multiply our original coordinates that we have by that factor of 1.5. That would make point A become -9, -6. Point B would become -6, -3. And point C would become -3, -7.5. And let's plot those points to see where they are. So -9, -6 would be right here. So that's our A prime. Point B is at -6, -3. And C prime is going to be at -3, -7.5, which is right here. And then if we connect all of our points in this image together, we can clearly see now that the relationship between our black triangle A prime, B prime, C prime, and triangle DEF is indeed a reflection across the x-axis, making the correct answer here, answer choice B, a reflection across the x-axis after a dilation of 1.5.